So somebody remember me to get rid of that one. We're done. Okay, so we got side square. This is the part that's going to be different from the disc and the washer. The rest is pretty much going to be same. Is anybody having trouble figuring out if it's in terms of X or Y?
Does it just depend on the square?
Yes, it's always, yes. In this case, yes. And the washers and the discs are pretty clear. It's supposed to be perpendicular to the axis of rotation. So, yes, and that will tell you that. So that's another good thing about cross sections. Okay. So this is right here is a square. All right. You're looking at it sideways. Okay. So this is what it looks like. This is your side, which is really this as well. Okay. So that is that right here. All right, so what is that length? Again, that's similar to how we did it with the washer and the disc too. What is that length? Radical x, we're in terms of x, minus 0. Very good. So over here, we put radical x, and it's a square, so we're squaring the side, change in x. Okay? Good. That's okay.
But if it's a square and you're like squaring it, that's the area. Why would you times it by the height? Wouldn't that be the
wait, remember volume is the area of the base times the height. This is the height of the solid. That's not a dumb question at all. Okay? That's the height of the solid, and this is the square, and you're just like, that's just like nothing, but it is a solid, so you have to count. Okay, so now we're ready to integrate. At radical x squared is x and dx. Okay, again, we're in terms of x, so we go from this big to little, which is 0 to 4. Okay, certainly easy enough. We can do this by hand. So what's that? X squared over 2 from 0 to 4. So 16 over 2 minus 0 is 8. Okay? So they tell you the cross-section figure. You have to figure out the area of it. But basically, you're talking for cross-sections, volume using cross-sections. You will take the area of the shape times the height of the solid, and this will be change in x or change in y. And we can determine that the same way we determined the if it hits the x or if it hits the y, it's in terms of x or y. Okay? All right, so let's try the next one when you're ready. The next page is just those figures I already showed you. So let's go on to the following page.
Is the area and shape always square?
No, they'll tell you what it is. Yep, they'll tell you what it is. All right, so we're using the same figure, that base B. So we got this time we're going to do y equals x, y equals 0, x equals 4, okay? Yes, it is, sorry. All right, there's that same base B, okay? But this time the squares are perpendicular to the y-axis, okay? So they're like this, okay? Now, if it didn't say cross sections, we would do a washer, right? Okay, but it doesn't say cross section, so we're not doing a washer, we're doing a cross section of square again. Okay, now typically you think it would be the same volume, but it sometimes is, it sometimes isn't. And that's what this solution sometimes differ when using different orientation. Shape is changed. Okay, so the volume is going to be different. Okay. So, remember, this is your square that sits sideways. This is the thickness of and that's change of light. Okay? So, volume of the cross-section is, in this case, area of the square times height, which is change in y. All right, the square. What is going to be its length? What is it? We'll start with the bigger number, which is 4, minus radical x. Yep.
Where is it y squared?
Okay. It is in terms of y, so right. 4 minus y squared equals x. Good. And we would have caught that when we got over there and they didn't match up. So good job catching that. So 4 minus y squared. Did we lose anybody? Got to use in terms of change in y. And because it's a square, we have to square it again because this is just a single side. So you're looking at a square on its side. The thickness is nothing. That's the thickness. That's each. Okay, go ahead and plug that one into your calculator. Just 0 to, what's my highest y? 2, right, because if this is 4 here, 4 what? Radical 4 is 2. Very good. So I bet you all did well today. You're answering the same questions that we had to use today, so that's good. You had homework today.
Oh, okay.
That's what I meant. Yeah. That's what I meant. This one actually gets kind of crazy by hand, but I did it. But all right. 0 to 2. It is because I multiplied it out first. So then you got y to the 4th, which means the antiderivative is y to the 5th over 5. It's just ugly. Squared again. X. All right. There's no pi involved here because there's no square. There's no circles. So 256/15 is fine, and so is honestly 17.067. Either one of those answers is perfect. Anybody get anything else? All right. Any questions about the process? It's a kind of a visual thing, but you're finding this radius the same. If this was a washer, you'd have to find that the same as you're going to find the side of the square. All right, so let's look at this. Calculate the volume of the solid with a base R. This is my base. That has a semicircle cross sections. So see the cross sections. Clue right there, perpendicular to the y-axis. So I've got one drawn here. That's my semicircle. On its side, it's like a protractor. Kind of, you can't see it. It's very visualizing. Okay. Yes. Okay. X squared plus y squared equals 25. All right. So that's my equation. Please note that. Oh, we won't go there yet. Okay. So is this going to be in terms of x or y? Y. All right. So volume of the cross section is. I'm going to say area of a semicircle this time, because that's what they told us we had, times the height. The height, we already said, was in terms of y. All right, how do I find the area of the semicircle again? 1/2 of hierarchy mark, okay? That's the worst part about the cross sections, that you have to know all the, well, that's one of it. You have to know all the formulas, or you can figure them out if you don't remember them. Okay, so R, this is a semicircle, okay? You're looking at a semicircle. It looks like this. This is what of the semicircle? Diameter. Okay, so let's figure out the diameter of the semicircle. If we figured out the radius of something else, washer, whatever, we can figure out the diameter, we'll figure out the radius, we'll be able to go into the formula. Okay, so how do I figure out the diameter? You need to know what this is minus this. Those are two different functions. This is one, and this is the other. There, right there. Solved for, not solved for x so we can have it in terms of y. No, not always. A lot of times they will, though. Okay, so what's the furthest point over here? This one? 25 minus y squared minus negative 25 minus y squared. The whole 25 minus y squared is in the is in the radical. All right, so what is that? 2 radical 25 minus y squared. Good, and that's the diameter. So what's my radius? One of those. That's right. Divide by 2. Okay? Does that make sense? All right. Okay, so here we go. We're going to put that in here. 1/2 pi r squared is going to be radical 25 minus y squared, change in y. Okay? All right, we're ready for an integration. I'm going to go ahead and put my pi and my 2 over there. There's no point putting those in the integration. And when we square a radical, we get no radical, so that's good. All right, what are my x? My y is bottom to top. What's my smallest value that I get? -5. Good job. We're down here at -5. And my top is 5. Okay? If you were doing this by hand, you might make mention of what kind of a function this is. Because of the -5 to 5 symmetry. Remember that? What's that, an even function? So you could do 2 of these. If you were doing it by hand, it might save you a little bit of time. That's what an even function does. Okay, the 2's cancel out, which is nice. Okay, so plug either one of those in and you should get a decent answer. I'll plug the simplified version in. Save the pi for later. If you want to just, if you're not doing, you could have multiplied this by pi right away. But sometimes they're just not pretty. But decimal, the 3 digits will always be acceptable, unless of course you have multiple choice, and that's not one of your choices. So 261.799, either one of those. Everybody get that? Very good. Yes, sorry.
I'm kind of confused, like, what's that change in y?
That's the semicircle, because that's how they told us it needed to be perpendicular to the y-axis. So that's the thickness of the semicircle. Like they're all laying there like this. They have no.
Well, then, can it be a line then?
Yeah, it is going to be everywhere anyway. So these are all stacked in here. But every one of the boundary is, you know, this curve minus this curve, this curve minus this curve, this curve minus this curve. Every one of the stacked semicircles that you have stacked there. Okay? Any other questions? It is a visual kind of conundrum. Is that a good word? To me. Okay? Just because it's, and this is, Calc 2 is real heavy 3-dimensional. So you want to, here's what I found my brother-in-law, who's not my brother-in-law, he's my friend in college. But we worked together in Calc 2 because he could draw and I could do the math. So together we were a great team. But you do have to visualize And if you can draw it, of course, you're visualizing it. And then if you can see it, you're like, oh, okay, that makes sense. So Calc 2 is real heavy on 3D. It's okay.
How do you know? You always start from the right minus the left.
Yeah, because that's a bigger number over here.
Okay,
You're finding the distance.
so we would change it at
Top.
1 minus
Minus 5, right, because your bigger number's on the top.
regardless of whether like the color section is like quadrant or like second.
Yes. Because if you're slicing up this way, like this, now you're doing this minus this. Oops, that's supposed to be. So your top number is red is always going to be bigger than the bottom number here. So if you want to change an X. And you do that when you do the radii anyway. You always start from the right over, right? Even though you draw, like when we were doing our washers, and let's say we have something like this and like this. You have a washer, you start here, and you have the inside one here. But when you're finding the distance, you always go from here to here. Have you not been doing that? Okay. And if it's 0, you don't really have to worry about that. But if it's not 0, you do. Okay. All right. Let's try this one. I think we have isosceles right triangles. Okay. The base of a certain solid is a plane region enclosed by the x-axis. Okay. And the curve y equals 1 minus x squared. So that looks like this up here, 1. And the x-axis right here. All right, so you can see the shape we've got, which is right here. That's what you're enclosing. Each cross section, so there you have the clue that you're supposed to use cross sections of the solid perpendicular to the y-axis. So that would be this. Okay, is an isosceles right triangle. Okay, with hypotenuse lying in R. So this right here is that. Okay. Now, if you can wrap your head around what that would look like, okay, if you can't, it's really okay because you can do it very methodically and get around that visual if you're not gifted like me and Abby. Right, Abby?
Oh, should wait.
I'm not gifted, y'all know I'm kidding, right? Okay.
Just like on the right side of that.
This is the whole thing is the hypotenuse. Okay? Yes, that's what they told us. A hypotenuse is lying in this R region. This is R. Okay, so you gotta be real careful. It's hard to visualize, isn't it?
Like snagging us like that.
I would say so, yes.
Okay.
Let's see if you're drawing. Yeah. Yeah. Do you want to see what Abby's talking about? I know we have more artists than just Abby here, but we just have a Aren't there any more artists in here? I mean, you don't have to like graphs. Okay, so Jessica's got all counts. And honestly, there are different degrees of artistry than me, who has none, and Abby, who has it all, right? There's some of you that are somewhere in between, I'm thinking. Okay?
Oh, yeah.
See, that's why you need to find an Abby in college who can draw.
Abby, what the heck are you
Well, we call it Abby in Calc 2. Abby, change your number right there. Okay? All right. But you can do it without visualizing. You have to be more careful about it. I was just getting that. Sorry.
I'm just kidding.
Which one? Oh, sorry.
I just finished. It's just I just need a phone.
Yeah. And honestly, I'm giving a lot of credit to those that can draw, but if you can visualize it, you're okay. I mean, I can visualize it, but I can't draw that.
I mean, like, so the solid.
It's a triangle solid.
So the triangle base.
I mean, this is the solid right here. You're just, it's sort of like, are we good here? It's sort of like, I had a picture like this one.
Just because it's on a graph doesn't mean it has to be curved.
Correct. See, this is almost looks like what we have here. The shape is different, but that almost looks like our isosceles triangle. Okay. All right. So here we go. Let's go back to the. All right. Where are we? Here. Okay. Now, isosceles right triangle. I already marked the right, but I got to mark the isosceles so I remember that. Okay. So let's take the hypotenuse. Just like on this one, we started with the diameter, we went to the radius. Okay. Who knows the formula for the area of an isosceles triangle? And the base and the height are the same, right? Okay. So area cross section 1/2. So I'll just say b squared. Or I'm going to call this b. Okay. And then change the height of the thing is going to be a change in y, because that's where we're hitting. Okay, so you have to be very, if you are not like, I'm not feeling that, you just have to be very methodical about drawing the hypotenuse that they told us, lying in R, perpendicular to the y-axis. There's your hypotenuse. Then you have to draw yourself a visual for the shape, and then you can get the rest of it all figured out. Okay, because you've got all the calculus that you need. Now the rest is geometry, linking that. Okay, don't leave anybody behind yet. I shouldn't say yet. All right. Okay, so I got to find B. First of all, this hypotenuse. What are my hypotenuses going to look like? This minus this, right? In terms of y, oh boy. So let's see. Y equals 1 minus x squared. So y minus 1 equals negative x squared, right? So negative y plus 1 equals x squared. So x equals plus or minus. Okay. So again, we have the shapes. This is the positive or the negative. Okay. And this one is the negative on the outside. Inside doesn't change. Okay? So when you're looking for this, every time you slice it up in that section, the red is the bigger number. So that's my hypotenuse. So I'm going to do this radical negative y plus 1 and subtract the green, which is negative radical y plus 1. I said it wrong. Right. Okay. Try that again. Okay, so that's my hypotenuse. All right, which is simplified how? Okay, good. That's my hypotenuse. Okay, so here we are. Back to geometry or special triangles, which we also did in pre-cal. So Reed's not completely out of the woods here. What is the relationship between the legs of an isosceles triangle and the hypotenuse? Not double. Yes, the leg times radical 2. So I got the leg times radical 2. What am I going to do to get a leg? Right, so 2 radical negative y plus 1 over radical 2. That looks ugly. Okay. Sorry, Angela. Got it? This is the leg, yes. Remember, the leg times radical 2 is the hypotenuse of the 45, 45, 90 triangle. So we have this. So we needed the leg, so we divided by radical 2. Okay. All right. So there, if you want to clean that 2 radical 2 up, you can. We're going to throw it in our calculators. I don't think it's worth the time, but if it really bothers you, do it. Because we would have done that pre-cal. We would have cleaned that up. Okay, so let's put that in for our B. I forgot what it was already. 2 negative y plus 1 radical over radical 2. And don't forget, we're going to square that anyway, because that's the 1/2 base times height that Kate said. So radical y. Okay? Do we need any of that piece again? You can do it yourself. I mean, see
By hand?
yeah. No, not the integral, but there's just a lot of pieces, and this piece was like a huge reach for, I mean, somebody that isn't comfortable with the whole 30, 60, 45. So anyway, I'm rambling. Okay. All right. So I'm going to pull. Let me just simplify. These 2's are going to cancel. No, I better not do that because I got to square, right? All right. So let's square first. 1/2. We got 4. We don't have a radical anymore, but and we have no radical on the bottom, and we have change in y. All right. Now I'm ready for a radical, finally. Okay. 4's are all going to cancel, aren't they? 2 times 2 and 4's are going to cancel. All right, so it ends up being halfway decent. dy. And we go from y is top to bottom. So 0 for sure to, what's that top one? That was a 1. And we're good to go. So the integral's the easy part here. So these are intense because of all the background that you have to. All that mess for a hack. All right. We just found that volume of this area that was sliced up like that. Okay. Any other questions? All right. Okay, let's go ahead and look at the homework.